In this video, what I'm going to do is solve this differential equation, x double dot plus 7x dot plus 10x is equal to 20 with the initial conditions x of 0 is equal to 5 and x dot of 0 is equal to 3. But I'm going to use this table, which is given in Palm's System Dynamics Engineering book. And the first thing we need to do is we need to determine what table entry we're going to use. Now, from this equation, we see this x double dot right here. So that x double dot means we are going to be working with a second order differential equation. But with a second order differential equation, there are four possibilities we need to consider. We need to consider which type of roots this second order differential equation is going to have. If it's going to be a distinct real root, repeated real root, imaginary root, or complex root. And the way we do that is by looking at these conditions right here. So we're going to look and see which one of these conditions are true, and that's going to tell us what type of root we have. A is going to be given by the coefficient in front of the x dot. B is going to be given by the coefficient in front of the x. Now, once we know what entry we're using, we are either going to use the entry in the table to figure out what our roots are, or we're going to have to do something over here with some sort of polynomial, sort of factor polynomial, or use a quadratic equation to figure out what our roots are. So then the last thing we can do is we can use this last entry to write the general form of the differential equation. The general form has all of these constants in it, and to figure out what the actual numerical value for the constants are, we need to use our given initial conditions. And that's how we're going to approach these problems. So the first thing, we have to determine the table entry that we're using. Like I said, our A variable is going to be the coefficient in front of the x dot. Our B variable is going to be the coefficient in front of the x. And our C variable, which we'll need when we're working with our solution, is going to be equal to what's on the other side of the equal sign, so 20. Okay, so the first test that we do, I'm just going to start and work my way down, even though the title of the video tells you which one this is. So I'm going to start with a squared is greater than b squared. In this case, I have a squared, which is 7 squared, which is 49, is greater than or equal to 4 times b, which is 4 times 10, or 40. And this is true. So right away, we got lucky this time, and we immediately know that we have distinct real roots. That means we're going to have two roots. They're going to be different numbers, and our general form of the equation is going to be given by this table entry right here. So now we actually have to get the roots. And to get the roots, what we're going to do is we're going to go back to the actual differential equation. So every time we see an x double dot, we are going to replace it with an s squared. If we see an x dot, we're going to replace it with an s. And if we see an x, we're going to replace it with nothing. So let's do that. And then we're going to equal that to 0. So we're going to have s squared. We're going to keep whatever coefficient we see in this equation. So plus 7s plus 10 is equal to 0. Now this becomes something we can factor. This polynomial we can factor pretty easily. We see that it's going to be s plus 5 times s plus 2 is equal to 0. We equate each of these terms to 0. So we have s plus 5 is equal to 0. We have s plus 2 is equal to 0. So we get our two roots. Our x is equal to minus 5 and s is equal to minus 2. Those are our two roots, and they are distinct. They are different numbers. Now the next thing is we want to write the general equation. And our general equation is going to be x of t, and we want to include any information that we have at the present time. So x of t is equal to C1. We don't know what our constants are, but e to the S1, we can pick which one of these is S1 and S2. It doesn't matter. So S1 is going to be minus 5. So minus 5t plus C2 times e to the minus 2t plus c over b. What is c over b? C is 20, b is 10. 20 divided by 10 is equal to 2, so plus 2. Now, this is my general form of the solution. But what I really need to do to finish this problem is I need to figure out what my coefficients of C1 and C2 are. In order to do that, what I need to do is use these initial conditions right here. So the first thing, what do these initial conditions mean? It means the value of my equation at time is equal to 0 is equal to 5. How I can write this is x of 0 is equal to C1 e to the minus 5 of 0 plus C2 e to the minus 2 of 0 plus 2. And really, this term right here, I don't need to write x of 0 because I have a value for that. I know that it's equal to 5. So 5 is equal to C1 e to the minus 5 times 0 plus C2 e to the minus 2 times 0 plus 2. Okay. And then what I actually can do is I know that 5 times a 0 is a 0, and e to a 0 is a 1. So both of these just become 1s, and I get 5 is equal to C1 plus C2 plus 2. But right now, I don't have enough information to solve this equation. I have 2 unknowns, but I only have one equation. But if we look at our initial condition, we have another initial condition right here, which is x dot. So the derivative of our x equation is going to be equal to 3 at time is equal to 0. So we can take this general equation right here, and we can say that x dot, if we differentiate this equation with respect to time, what do we get? Okay, so we're going to get minus 5 C1 e to the minus 5t plus minus, because it's a minus 2 C2 e to the minus 2t, and the 2 is a constant and it goes away. We can do the same thing that we did in this term right here. So we can say x dot of 0 is equal to minus 5 times C1 e to the minus 5, 0, minus 2 times C2 e to the minus 2 times 0. Again, our e's are going to go away because e to the minus 5 times 0 is really e to the 0, which is 1. So we also need to say, okay, at time 0, what do we have? We have this is equal to 3. So our equation is 3 is equal to minus 5c1 minus 2c2. Now we have enough equations, and I'm just going to star them so I don't lose them. But these are the 2 equations we have, and these are the 2 unknowns we have. So finally, we can substitute. We can solve these 2 equations. I'm going to choose to substitute. I'm going to call this equation 1, and I'm going to call this equation 2. I'm going to solve 1 for, say, C1. So here I'll have C1 is equal to, if I move the 2 over, I get a 3. I subtract the C2 over, I get minus C2. Then I'm going to substitute, we can call this equation 3 for no reason really, but 3 into 2, and I'll get 3 is equal to minus 5 times 3 minus C2. So I substituted this equation in right here. And then I have minus 2C2. Okay, this is equal to minus 15 plus 5C2 minus 2C2. Okay, 18 is equal to 3C2. And I could solve for C2, and I get C2 is equal to 6. All right, now that I know what C2 is, I can substitute back into this equation, and what I can get is C1 is equal to 3 minus 6. And this is equal to minus 3. So C1 is equal to minus 3. So now the last thing we need to do is take these two constants and put them into this equation over here. X of t is equal to C1. So minus 3 e to the minus 5t plus C2. So plus 6 e to the minus 2t plus 2. So this is our solution with solved for our constants using our initial conditions. So hopefully this video has helped you learn how to solve a differential equation using the table presented by Palm's System Dynamics book and be able to determine which second order table value we'll use, how to figure out the roots, how to find the general solution, and how to solve for the constants in a differential equation.